is the rate of change of f with respect to z in the situation we are considering. So this quantity is what we call partial f over partial z with y held constant. That's what we wanted to find. Okay? So now let's see another way to do the same calculation. And then you can choose which one you prefer. So the other method is using the chain rule. Okay, so let's use the chain rule to understand how f depends on z when y is held constant. So let me first write the chain rule brutally, and then we'll try to analyze what's going on. So you can just use the version that I have up there as a template to see what's going on. But I'm going to explain it more carefully again. Okay, so that's the most mechanical and mindless way of writing down the chain rule. I'm just saying here, let's say that I'm varying z, keeping y constant, and I want to know how f changes. Well, f might change because x might change, y might change, and z might change. Now, how quickly does x change? Well, the rate of change of x in this situation is partial x partial z with y held constant. So if I change x at this rate, then f will change at that rate. Now, y might change. So the rate of change of y would be the rate of change of y with respect to z, holding y constant. Wait a second. If y is held constant, then y doesn't change. So actually this guy is 0, and you didn't really have to write that term, but I wrote it just to be systematic. Okay? If y had been somehow able to change at a certain rate, then that would have caused f to change at that rate. Of course, if f is held constant, sorry, if y is held constant, then nothing happens here. And finally, well, z is changing at a certain rate. This rate is this one. And that causes f to change at that rate. And then we add the effects together. Okay, see, it's nothing but the good old chain rule. Just I've put these extra subscripts to tell us what is held constant and what isn't. Okay? Now, of course, we can simplify it a bit more, because here, how quickly does z change if I'm changing z? Well, the rate of change of z with respect to itself is just 1. Okay? So in fact, the really mysterious part of this is the one here, which is the rate of change of x with respect to z. And to find that, we have to understand the constraint. Okay? So how can we find the rate of change of x with respect to z? Well, we could use differentials like we did here, but we can also keep using the chain rule. So how can I do that? Well, I can just look at how g would change with respect to z when y is held constant. So I just do the same calculation, but with g instead of f. But before I do it, let's ask ourselves first, what is this equal to? Well, if g is held constant, then when we vary z, keeping y constant and changing x, well, g still doesn't change. It's held constant. So in fact, that should be 0. Okay, but if we just say that, we're not going to get to that. So let's see how we can compute that using the chain rule. Well, the chain rule tells us G changes because X, Y, and Z change. Okay? How does it change because of X? Well, partial G, partial X times the rate of change of X. How does it change because of Y? Well, partial G, partial Y times the rate of change of Y. But of course, if you're smarter than me, then you don't need to actually write this one because Y is held constant. And then there's the rate of change because Z changes. And how quickly Z changes here, of course, is 1. Okay? So out of this, you get that. Well, I'm tired of writing partial G, partial X. So let me just write G sub X times partial X, partial Z, Y constant, plus G sub Z. Okay, and now we found how X depends on Z. Partial X, partial Z with Y held constant is negative G sub Z over G sub X. Now we plug this into that and we get our answer. I guess it goes all the way up here. Okay. And then we get the answer. I'm not going to, well, I guess I can write it again. So there was partial F, partial X times this guy minus G sub Z over G sub X plus partial F over partial Z. And you can observe that this is exactly the same formula that we had over here. In fact, let's compare these two methods side by side. I claim we did exactly the same thing, just with different notations. See, if you take the differential of F and you divide it by dz in this situation where Y is held constant and so on, you get exactly this chain rule up there. Right? That chain rule up there is this guy, df, divided by dz with Y held constant.